Alright, hello everyone, April 15th. Alright, let's do this. Good triplets in an array. 2 0 indexed nums1, nums2, length n, both of which are permutations of this. A good triplet is a set of 3 distinct values which are present in increasing order. A set of 3 distinct values which are present in increasing order by position, both in nums1, nums2. In other words, if we consider position 1 as the index of the value of v in nums1 and position 2 as the index of value of v in nums2, then a good triplet will be set as xyz, where they're within this, such that position 1 x, position 1, wait, hold a second, index of value of v in nums1, and then position 2. Hold on, there are 4 triplets xyz such that 2 0 1 position 1x position 1 v index of value v nums1. Is that index? This is index. So I have 2 0 1 3. They're going 1 2 3 4. 0 1 2 3. So I say how many triplets satisfy? 0 1 2, 0 1 2, 0 1 3, 0 2 3, and then 1 2 3. Yeah, we have 4 that satisfy. And then we have to go down there. And down there is 0 1 2 3, right? So 0 1 2 basically is 2 0 1. So I need 2 0 to follow. It doesn't follow. 0 1 3, 0 1 3. Right? Oh, hold on. 0 1 3 is 2 1 3. That doesn't follow. 0 2 3 doesn't follow. 1 2 3. Wait, hold a second. All of these triplets, only 0 1 3. Yes, a value 0 1 3, 0 1 3. So essentially we want, it can be any triplets, right? It doesn't really matter. It's just any triplet from here, such that in here they still have in here the order is still the same. Yes, basically it's just the order. We want to see that the order is still the same. Okay, so I have another example. 4 0 1 3 2, and I have 4 1 0 2 3. So 4, right, I can pick 0, and then I can pick 3, so I have 403 or 402, right? Now if I start with 0, it doesn't work because 0, 1, 1 is to the left, 0, 3, but then I have nothing, 0, 2, this one has nothing, so 0 doesn't work. Now with 1, I have 1, 0 doesn't work, 2 doesn't work, 3 doesn't work. I go to 3, 3 isn't here, doesn't work. I go 2, it also doesn't work. So my answer is just these two, but they said a 4. Oh, I only checked for 0. You have to only check for 1. Oh yeah, 4, 1, 3, and 4, 1, 2. Triplets follow the same order. So if I zero in on the center value, right? If I zero in on center, so nums 1, right? I have something, 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 and then something, 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 something. If I center on this value, then the triplets are anyone on the left, anyone on the right. Right? We have that many. So like for 1, we have basically 4 different ways to form the triplets. So now I go to nums 2, right? I go for the same question mark. Then we have bunch here, I have bunch here. Now the question is basically, what's the overlap between here and here? What's the overlap between here and here? If you find the overlap, and then you just multiply them, and that shall work. Which means if I go back to this example, 2, 0, 1, 3, and then 0, 1, 2, 3. So I say I pick 0 as the middle, then this 0 has to be the middle. 0 is not a middle, so that is not going to work. And I say I pick 1 as the middle. Okay, it is 1. And here I have 2, 0, I have 0, 1, so we have 0, right? And now we have 1, 3, I have 2, 3, so I have 3, so we have 1. So in this example, 4, 0, 1, 3, 2. 4, 1, 0, 2, 3. Again, we pick 0. On the left, we have 1. On the right, we have 2. So times 2 equals 2. I pick 1, it's the same, right? I pick 3, doesn't work. I pick 2, doesn't work. So plus them together is 4. So if we want to go down this path, we're starting from this position, okay? I check this. I know what's on the left, right? I do know what's on the left. And I also know what's here is a little bit tricky. I don't really know what's on the left because I need to find where it is. I can find where it is. I can do a map. So immediately I know the position of this, okay? So I know the position. Then I have everything like with the position smaller. But how do I find out what is the mapping? I can say I'm here, right? And then for every single letter, for every single one on the left, I know what the position here as well. So I say I'll count. And the thing is, as I move forward, the ones that used to work will continue to work, right? So I just keep count how many is on the left hand side. So I'm here and I check this is on the left hand side or is not on the left hand if this is on the left hand side. So basically this one I'll produce a map of 4 is going to be 0, 1 is going to be 1, 0 going to be 2, 2 going to be 3, and 3 going to be 4. So this is the position. So I'm here and I check this one is 0, it's smaller than this, which means it's a match. So I count, that's a 1. Okay, and on the right hand side, so basically I need to go through the entire thing. Okay, now I find 2 is on the right, 3 is on the right, and that's it. So on the right hand side, so it's the left. Basically left I have 1, on the right I have 2, right? Okay, and then it's like a sliding window, and now I move here. So this, well, check if we can add inside, and this is 0 is 2, and it's also 2, so it cannot add inside. On the right hand side I need to remove 1, and when I remove 1, it's just to see if 1 used to be on the right hand side, and here 1 is not in the right hand side, so I remove 1, doesn't really matter, right? So here it's still 1 and 2, but next when I move here 1, so the left basically plus 1 become 2 because 1 is in, right? And then we remove 3, so 3 used to be in, right? 3 used to be in, so I remove it, so this is basically become 1. Oh, you remove 3, but 2 gets affected as well. Okay, so this direction is fine, but the other direction is not fine. And maybe I can do 2 rounds because I feel I go this way, I can keep adding, but then the ones on the right gets ignored. Like I cannot handle 2. I move here, I remove every single one, but 2 also needs to get removed, but I don't know that. So I can do a left array, right? When the middle is at this, right? So the middle position, I can keep track of what's so the start is going to be 0. So middle at this, it's 1. Middle at this is still 1. Middle at this is going to be 2 because I have 4, 1. And then middle, that's it. At the end, I don't have to do the end, but that's basically on the left. So on the right, I move right to left, right to left. So first is going to be 0. So now I move here, right? I'm starting here, and I have 2. 2 doesn't work, so that's still 0, right? And then I move here. Now I have so you hit the same problem. The 2 is not part of it, but as you move, 2 becomes part of it. Oh, how do I handle that? So as I move, right, and I think it will happen to the other one as well. So as I move forward, so I have the starting point, like in this case, starting point is 2, and I check 2 is not, at least at this point, 2 is not part of it. And then I move forward. We can just set a set. A set, wait, hold on, why did you say a set? Yeah, we can have a set. because as I move forward, I have a set on here, right? So essentially, initial set is 2, right? And then I'll check this, right? If this is in this, it's not, then yeah, don't handle. But as I move forward, so yeah, as I move forward, I'll add new ones here, and then once I add new ones here, I can use this indices to check if it's part of it, right? I can check if it's part of it, like if this is included in here. But at the same time, once I move forward, I also have new ones in here. Now we want to see if this gets included. So I have two maps, right? Because as I move this one forward, but you should also know where this is on the bottom, right? Yeah, so like I'm now saying it's going to be 1, then it should, and then the 1 is here, then it's these 3. Oh, they're not like perfectly matched. So I have a middle value, and I can check my bottom middle value. Then I can check if this value is within the range. And I check if this value is within the range, right? Which means just at this position, because at any position, I have these numbers on my left, so I just want to know if they are in range. But when they check if they're in range, it has to be specific to my value, right? Okay, let's say we check with this done. Now we move on to the next one, right? We move on to the next one. The previous result might not be applicable because as I move to the next one, the matched position changes, right? I can change to a different position. Now if I change to a different position, then whatever was used to do is no longer valid. You have to redo it. And now we go to O(n) squared territory, which we don't want. So there gotta be a better way than this, but I feel like I'm on the right track. I just need to figure it out. I just need to figure out for each position how much overlap is for the 2 arms. There gotta be an overlap, right? I can do a prefix array. That's going to be very big, but I can do a prefix array, prefix set, but then that's going to cost a lot of time. Yeah, and I'm just thinking, I am at a certain position, and I have the things to my left, right? And then I already checked that, let's say one of them is working, the other one is not working. And now I move forward, okay? Now move forward. The one that is working will continue to work. That is true. The one that used to work. Oh, that's actually not true. Because I can have, yeah, the one used to work, but then I move forward, they have like a swap, and it no longer works. Huh. Damn. How do I quickly find overlaps? I know the index, so I know the prefix. Right? I know the prefix. I know the prefix. I know the prefix of both, but finding their overlap is a little bit tricky. I feel like we'll have to copy and paste this one again. But the bad part is I don't really have a good idea at the moment. No clue. I mean, I have an idea, but I feel like it's not as easily implementable. Yeah, I can make a connection, and then I have a bunch of numbers on the left, bunch of numbers on the right. Or I can just focus put the number on the left, because on the right it follows the same. As I go through them, right, every one, I, record where they are. Okay, where they are. So I record where they are. And then I move on to the next one. I record where they are. Cool. Alright, here is a thought. Okay. I'll keep them sorted. We can use a sorted set, ordered set. So every time when I go left to right, every index that I encounter, I put it into sorted set, into the ordered set. The next one I put in ordered set. And because it's ordered set, I can binary search to find how many in this ordered set. Right? Essentially, it's just a ordered set of indices in the second one that is part of the first one, and then I'll binary search to find, and then I do it again from right to left, doing exact the same thing, and then I do okay, that's actually a solution. That is actually a solution, but I'm not implementing it today. It's kind of late. That is a solution. So we have an idea. I'll just. Oh, I'm not using Fenwick tree. Well, just not today for sure. So we should mention this is a copy and paste. This is a copy and paste. Yeah, must solve this one again. Yeah, this is just to satisfy this requirement. but we need to solve it again, just like we have to do this one again as well. So yeah, nothing to be happy about. Definitely, like the solution I have in mind is not going to perform as well. It's going to be O and log n, but it will work. Yeah, I have the idea. I just don't want to implement it today. That's all there is.